As a teenager, it's probably not surprising that I find myself being pulled in the direction of girls at my high school. But what if I told you I'm also being pulled in the direction of the camera and the curtain behind me, and I'm also pulling on these objects? This is the fundamental concept behind Newton's law of universal gravitation. This law is summarized in the equation here. It states that the force of gravity between two objects is equal to the universal constant times the mass of the first object times the mass of the second object divided by the distance between the center of those two objects squared. The direction of this force, because it is a vector, is towards what's called the center of mass for a system. This center of mass is located at such a location where the distance between the center of mass and the center of the larger or more massive object times the mass of the larger object is equal to the distance between the center of mass for the system and the center of the smaller mass times the mass of the smaller object. It satisfies this system of equations here. Now, what can you do with Newton's universal law of gravitation? Many things. The most common application used is to calculate the acceleration due to gravity near the Earth's surface, but it has a lot more practical applications too, such as the acceleration due to gravity of satellites, the force of gravity between the stars and planets, or the force of gravity between the planets on each other. It really is a universal law.